Hi. If you're watching this video, it is because unfortunately you did not pass the pre-assessment on solving one-step inequalities. That's okay. You're going to take some notes and then try again. So today we're dealing with using addition, subtraction, multiplication, or division to solve an inequality. This is not anything new. This is stuff that you have already done. So let's start with example 1. What I'm going to do is I'm going to demonstrate using my magic pen that when we solve inequalities, this is going to disappear, by the way. It is exactly like solving equations. So if this were an equation, we would add, and I don't want yellow, we would add 6 to both sides to solve that. Okay, and then this is going to end up being x is greater than or equal to -4. I am going to write a number line. I need you to write it as well. Let's put the -4 there, but let's put 1 point on either side of the -4 as well. Our solution set is going to be a point at -4, but the fact that we have an inequality symbol, this greater than, means we're also graphing everything that is greater than -4. So this is read as greater than or equal to. I want to talk for just a minute about when we just finished our section on equations. So if this solution set were x equals -4, and I were to graph this, that would end up being a point, just a single point at -4, which is one solution. We just finished that. However, in our case, we have infinite solutions. And this is why. If we were going to check, let's check to see if any of these points that are to the right of -4 are truly solutions. So let's go ahead and check. I'm just going to demonstrate it in a different color. -3. Is -3 a solution? So I would say is -3, I'm plugging it in right there, is -3 greater than or equal to -4? Yes, it is. So that works. How about if we chose -2? Okay, so let's put a little dot there and a question mark. What about -2? Is that greater than or equal to -4? Yes, it also is. But so is -2.5, -3.5, -2 1/4, -2 and 3/4. So the thing is, every little point on this number line, and there are infinite points between each of these whole numbers or integers, is actually a solution of the set. So this is infinite solutions. When you graph all these little individual points, picture making little circles here, you're going to end up with a line. So it's infinite solutions. We are comparing one solution, okay, one solution for equations to infinite solutions for inequalities. Please keep that in mind. Let's go ahead and try these two examples. Okay, I'm going to go a little bit faster. So just like this were an equation, I would subtract 8 from both sides. This ends up being y is less than or equal to -3. And here is our solution set. There's our -3, our -2, our -4. We're going to put a closed dot at the -3, and we want solutions that are less than or equal to -3. So we're graphing to the left instead. Again, infinite solutions. Let's do this last one. If this were something you were trying to solve, I want to remind you that you're moving the constant term or anything that is associated with the variable away. So that variable stays, which means we're moving the 1.4. So I'm going to subtract 1.4 from both sides, and I get m is greater than -9.4. There's another way to write this. I want you to write this too. You can flip this whole thing and say m is greater than -9.4. The only difference in this is that we switched the variable to the other side. Okay, so essentially all we did is we just flipped the whole thing. I want you to note that the larger part, or the large mouth, that's how I learned it, is still facing the m, or the variable, when we flip it, and it has to work that way. So this is going to be our number line. I'm going to put, let's do a -11, a -10, a -9, and then -8 on this number line. -9.4 is probably going to be right about here. Now this time it is an open circle, and we want everything that is greater than negative 9.4. So we're going to the right. I want to do a quick reminder. If you didn't remember this, put this somewhere, maybe in the margin. If we have a greater than or a less than symbol, we're going to have an open circle on the number line. If we have greater than or equal to or less than or equal to, this is going to be a closed circle. So please make sure that you remember that. Let's do this next example. Now we are dealing with multiplication and division. There is something special you have to remember. So I'm going to put a little asterisk here. I want you to do the same. Say, please watch for multiplying or dividing by a negative. And again, this is... I'm using a microphone. I don't know if you heard my dogs go crazy. I'm screencasting from home, but yeah, they probably, came through the microphone. So there you go, all three of my dogs. They said hello. I want you to please watch for multiplying or dividing by a negative and see if you can remember why. Why do we need to watch for that? Let's go ahead and solve. This is x over 8 is greater than negative 5. We are going to use inverse operations. We're going to multiply times 8 on both sides, just like we would if this were an equation. These cancel out here, and we have x is greater than negative 40. This is an inequality. Here is our negative 40. We're going to go negative 41 and negative 39. We want everything greater than negative 40, so to the right. And it's an open circle. Please note that I was watching for multiplying by a negative, okay? And it wasn't negative, it was positive, so there was nothing special I had to do. Let's solve this next one. So letter B, we have negative 24 is greater than or equal to 3x. If this were an equation, we would divide by 3, okay? And these cancel over here on this side, so I have x is less than or equal to negative 8. I'm going to switch that, or x is less than or equal to negative 8. I'm just going to swap the whole thing. It is a good idea to try and get into the habit of keeping that variable on the left-hand side. You will see why tomorrow when we take notes as a class. Here is my solution set, negative 8, negative 7, negative 6, closed circle at negative 8. And I want everything to the left or less than. Again, I was watching, I hope you were too, when I divided by the 3, I made note, was that negative? No, it was not, so I did not have to do anything special. So now let's deal with what happens when we have special solutions. I'm sorry, not special solutions, but when we are multiplying or dividing by a negative. Skip number 1. I don't think you even have it. You might, but let's skip it. Let's jump right to number 2. I need to isolate the w, so here we go. I am dividing by a negative 15. Okay, now immediately my watch out little alarm should go off. That is a negative, and I am dividing. This only works with multiplication and division. If you want to write that to yourself, only with multiplication or division, you need to flip the inequality sign. And I'm hoping that you remembered that. So even before I solve this, I'm going to flip the inequality sign the other way. All right, that w still stays over there on the right, and I end up with a negative 6.4 divided by a negative 15. It's a really small number. It's a 0.43, and you can just follow along on that. You don't have to do that on your calculator. I already did that. Okay, let's check and see if the solutions work, because we flipped the inequality sign. So I'm going to label it this way. We're going to go 0, 1, 2, and leave some space. If I were to graph 0.3 right there, it'd probably be right there. And I am, based on my solution set, I'm graphing everything that is to the right. Okay, because we want everything that is greater than. Well, let's try. How about number 1? Let's try a 1 and see if that works. So I plug the 1 in right there. I get 0.43 is less than or equal to 1. Is that true? Yes, it is. Okay, so in checking your solutions, you just have to check 1 on either side. Let's check a 0 and see what happens. Okay, so 0.43 is less than or equal to 0. No, that is not true. Okay, so the deal is we shade everything that is to the right. And we got that correct because we flipped the inequality sign. So when you're multiplying or dividing by a negative, flip the inequality sign. I'm going to have you pause the video for just a couple moments, and I would like you to do 3 and 4 on your own. Okay, and when you play it again, you're going to see the answers pop in. And then we will do one more little practice set, and you can go ahead and move on to the next assignment. So pause the video, please. Okay, for this next one, you had to divide by 4, so b is greater than or equal to 9. Okay, and here is your solution set. There's a 9, closed circle, and to the right. Here we have to divide by a 1.5, divide by a 1.5. I want you to note, and this is what throws people off, I am dividing by a positive number. Even though when I divide here, let me put this in like a disappearing pen here, even though on this side, I'm dividing it into a negative number. That's okay. You still don't flip the sign unless it's actually a negative number that you are multiplying or dividing by. So this ends up being a negative 12 is greater than q. We're going to graph this. And we are going to flip this. Q is less than negative 12. Oh, this is magic pen, so it's disappearing. Great. Let's fix that. So you have Q is less than negative 12. There's my negative 12. I'm going to go less than that way. Okay. All right. Here we go. I don't have any. Okay, let's do this. I want you to try this one. Negative 3x is less than or equal to 15. Okay, pause the video. Okay, and you had to divide by a negative 3, divide by a negative 3, so flip the sign. This is going to be x is greater than or equal to a negative 5. Okay, so there's your negative 5, closed circle, and we're doing greater than or equal to. All right, thank you, and move on to the next assignment, which is Big Ideas Practice.